Good afternoon, everybody. Today we are moving on to lesson 4, again in our equation review. Okay, so here are our student outcomes for today. Be sure to copy these down into your notes. The students are going to extend the use of the properties of equality to solve linear equations having rational coefficients. Okay, so today we're finally getting to the point where we can solve linear equations. If you need more time to write this stuff down, this video is on my YouTube channel, so feel free to go back and watch it as many times as you would like. So let's develop our concept a little bit. So to solve an equation means we want to find all of the numbers x if they exist so that the given equation is true. Remember yesterday we were given values of x and we were asked to decide whether or not that made the equation true. Today we're going to find the values of x that make it true. Okay? And again, if they exist, sometimes they might not. In some cases, some simple guesswork can lead us to a solution. For example, consider this equation. 4x plus 1 equals 13. And we want to know what number, what value of x would make this equation true. Okay? Or what value of x would make the left side equal the right side. Okay? Take a minute to guess. Some of you are probably shouting out the answer already. Okay? So, it's pretty clear that x would equal 3, right? 4 times 3 is 12, 12 plus 1 is 13. So sometimes in a simple equation, it's very easy just to guess the answer, or to look at it and logically conclude what the answer is. In other cases, guessing the correct answer is not so easy. Consider this equation. 3 times the quantity 4x minus 9 plus 10 is equal to 15x plus 2 plus 7x. Can you guess a number for x that would make this equation true? Go ahead and throw out there whatever random guess you would like. Okay, so obviously you don't really know whether or not it's going to be true. Okay, so we have to have a better method, because guessing is not always an efficient strategy for solving equations. Now we could guess some values, plug them in and see if they work, but if we don't guess close to the right answer from the start, we could be guessing for a long time. So in the last example, there are several terms in each of the linear expressions comprising the equation. This makes it more difficult to easily guess a solution. For this reason, we want to use what we know about the properties of equality to transform equations into equations with fewer terms. Essentially, that means we want to solve it, so we know exactly what it is. Our ultimate goal in solving any equation is to get it into a form of x, or whatever symbol is being used, so that could be any variable x, y, r, w, is equal to a constant. What is a constant? Remember, a constant equals a number. Okay, a constant is a number. So in order to solve an equation, we want x to equal a number. We want y to equal a number. We want z to equal a number. Whatever variable we're using, we want that to be by itself equal to a number. And that's what our answer or our solution is going to be. And that's what we're looking for when we solve an equation. So let's do a quick activity here. Take a look at this equation. Why don't you write it down in your notes? I'm going to tell you to do several things to this equation. I want you to follow along. So let me find it here. All right, here's what I want you to do. Take that equation, and first of all, is it true? Yes, it's true. Both sides are equal to 5. So we have 5 equals 5. Okay, both sides equal 5. Yeah, it's true. So here's what I want you to do. Now pay attention, listen carefully. I want you to add 3 to both sides of the equal sign. Okay, now you're going to add 3 to the left side of the equal sign. Add 2 to the right side of the equal sign. Now subtract 6 from both sides of the equal sign. Now subtract 3 from one side of the equal sign, and then subtract 3 from the other side of the equal sign. The next thing is you're going to multiply both sides of the equal sign by 10. So multiply both sides by 10. And then you're going to multiply the left side of the equation by 10 and the right side of the equation by 4. Okay, so multiply the left side of the equation by 10 and the right side of the equation by 4, and divide both sides of the equation by 2. Divide the left side of the equation by 2 and the right side of the equation by 5. Okay, what do you notice? Is the equation still true? Okay, well, let's go through and find out. So the first thing I told you to do was add 3 to both sides of the equal sign. I get 8 equals 8. Then I said add 3 to the left side and add 2 to the right. So here I have 11, here I have 10. Okay, now I subtract 6 from both sides. 5 is equal to 4. Okay. And now I'm going to subtract 3 from one side and 3 from the other side. Then I'm going to multiply both sides of the equal sign by 10. And I'll move over here. 20 is equal to 10. Multiply the left side of the equation by 10 and the right side by 4. So 20 times 10 is 200. 10 times 4 is 40. Then I'm going to divide both sides of the equation by 2. 100 is equal to 20. And then I'm going to divide the left side of the equation by 2. And I'm going to divide the right side of the equation by 5. Okay. So, is the equation still true? No, it's not still true. Now I get 50 equals 4. How come? Why is it not the same? Hopefully most of you are saying because you didn't do the same operations to both sides of the equal sign. We started with a true statement. Okay? If we start with a true statement, as long as we do the same thing to both sides of the equal sign, we're going to end with a true statement. The problem is when we don't do the same thing to both sides. Here I added 2 and I added 3. Here's the same. Here I multiplied by 4 instead of 10. Here I divided by 5 instead of 2. Okay? When you don't do the same thing on both sides of the equal sign, you're not going to end up with a true statement. Okay? So those are our properties of equality. There are 4 of them that allow us to transform an equation into the form we want. Okay, so A, B, and C are any rational numbers. So if A equals B, then A plus C is equal to B plus C, which means I can add the same thing to both sides of the equal sign, and it won't change the equality of my equation. Okay. The next one is the subtraction. I can subtract the same thing from both sides, and it doesn't change the equality. The multiplication property. I multiply both sides by the same thing, it doesn't change, and I can divide both sides by the same thing. So, all 4 properties require us to start off with A equals B. That is, we have to assume that a given equation has an expression on the left side that is equal to the expression on the right side. Working under that assumption, each time we use one of the properties of equality, we are transforming the equation into another equation that is also true. That is, the left side equals the right side. Okay? So the main point here is when we are solving, okay, we start with a true equation, we have to assume it's true, and then we're going to do the same thing to the left side as we do to the right. So here, solve the linear equation 2x minus 3 is equal to 4x for the number x. So we want to get x by itself. Now, there's lots of things we could do in order to start doing that. Okay? But the best one is probably to get the x's on the same side. So how can I get all of my x's on the same side? I want to combine my like terms. 2 possibilities. I could subtract 4x from both sides, or I could subtract 2x. Okay? Either one is correct, but one of them is a lot easier. So I'll start by subtracting 4x. Okay? So if I subtract 4x from both sides, I end up with 2x minus 4x is negative 2x minus 3 equals 0. Now I need to add 3 to both sides. Okay, inverse operation. These cancel. Negative 2x is equal to 3. Divide both sides by negative 2. And I get x to equal a negative 3 over 2, which is a negative 1 1/2. Okay, so you see I end up with my answer of negative 3 over 2. Okay, a lot of times the part kids miss in this problem will be the 0. They lose the 0. Okay, here's the way I'd prefer to do it. 2x minus 3 is equal to 4x. I'm going to subtract the 2x. Okay, when I subtract 2x, I get negative 3 is equal to 2x. Now to get x by itself, all I need to do is divide by 2. And I get x is equal to negative 3 over 2. It's one less step, and it's a lot easier to follow. Okay, and I end up with the same answer. So I know that when x is equal to negative 3 over 2, I know this equation will be true. If you want to check your answer, all you need to do is plug it back in to the equation, just like we did yesterday to see if it makes the equation true. So 2 times negative 3 over 2 minus 3 is equal to 4 times negative 3 over 2. So here, 2 times a negative 3 over 2, this cancels. I'm left with negative 3 minus 3. Here, this cancels with a 2. I'm left with a 2 out here. 2 times negative 3 is negative 6. Negative 3 minus 3 is negative 6. Negative 6 equals negative 6. It checks out. So yes, negative 3 over 2 is a solution because it makes the equation true. Okay, so again, we're using our inverse operations. We want to end up with x equals a number. Okay, and this was our number. That's our solution. Okay. Example number 2. It says solve the linear equation 3/5 x minus 21 equals 15. And it says, here's a note. Keep in mind that our goal is to transform the equation so that it is in the form of x equal to a constant. If we assume that the equation is true for some number x, which property would we use to help us reach our goal? And how should we use it? Okay. So think about that. Which property would you use? Okay. The first one I would use, would be the addition property of equality, which says I can add the same number to both sides of the equal sign and it'll still be true. The reason I would do that is so that I can get rid of this negative 21. I want to get x by itself. This negative 21 is in the way. So I'm going to add 21 to both sides to get rid of it. When I do that, it cancels here. I'm left with 3/5 x, okay, is equal to 15 plus 21 is going to be 36. Okay. Now, in order to get rid of a fraction on my variable, I multiply by the reciprocal. If you remember, the reciprocal of 3/5 is going to be 5/3. To find the reciprocal, we flip the fraction. The reciprocal of 1/2 is 2, or 2 over 1. The reciprocal of 3 would be 1/3. The reciprocal of 2/3 would be 3/2. Okay, those are reciprocals. So you multiply by the reciprocal. 5 over 3. Whatever I do to one side, I do to the other side. That is my multiplication property of equality. Okay, these cancel. I'm left with x is equal to, now I can do some cross reducing just like I did in the 7th grade. Okay, this is a 3 on the bottom, that goes to a 1. The 36 on the top now becomes a 12. Okay, so I'm left with 12 times 5. 12 times 5 is 60. Okay, so x equals 60. The value of x that makes that equation true is 60. Okay, and again, if you want to check it, you don't believe me that that is the correct answer, you take 3/5 times 60 minus 21 is equal to 15. And again, this 5 cancels out and it turns to a 1. The 60 turns to a 12. 12 times 3 is 36. 36 minus 21 okay, should be 15. 36 minus 20 is 16, minus one more is 15, and 15 equals 15, so it checks out. Okay, and again, that's the same thing we were doing yesterday, plugging in to see if it makes the equation true. So x equals 60. 60 is the solution to our equation. Okay, and the key point on that one is, remember that to get rid of a fraction, we want to multiply by the reciprocal. Okay, because we can cross reduce everything out of there. Okay. So if we move on to example number 3, okay, the properties of equality are not the only properties we can use with equations. What other properties do we know that could make solving an equation more efficient? Okay. Well, really, the distributive property, which allows us to combine x's on the same side, would really help us solve them a lot more quickly. Okay, we wouldn't have to get everything together. Okay, also our commutative and associative properties, which allow us to move them around, okay, which means we can add or multiply in different orders, helps us to simplify each side before we start using our properties of equality to get rid of terms. So is there anything we can do to the linear expression on the left to transform it into an expression with fewer terms? Yes, there is. Okay, so here's our expression on the left. Here I have 1/5 x and x, or 1x. So I can transform that into 1 1/5 x. I can add those together. Okay, or I can say that would be 6 over 5x. Okay, which I'm going to do. 6 over 5x plus 13 equals, how about on the right side? Is there anything I can do on the right side? Yes. I don't have any variable terms that I can combine, but I have 1 and 22. Add those together and I get 23. Now it's a whole lot simpler to solve. Okay. So in order to solve, well, let's see. What does my next one say? Yeah, so here's the next one. It says example 3. Is there anything we can do to the right side? Yes. And then we get down to this equation here. What should we do now to solve the equation? So I'm going to go ahead and keep going with the one I have written down. It's mathematically identical other than the fact that I flip-flopped the 9x and the 23. It's the same. Okay, so I'm going to keep going with this one. What should we do next? Okay, lots of different options, lots of choices. The one I like the best is getting the x's on the same side. Now, what that means is I can add 9x to both sides, or I could subtract 6/5 x from both sides. Personally, I like to keep the variable on my x positive if possible, so I'm going to add 9x to both sides. Okay, now when I do that, I got to add a fraction here, right? So this is 6/5 x plus 9x. So I need to write 9 with a denominator of 5. So I think, what do I divide by 5 to get 9? Well, that's 45. So I have 6 over 5x plus 45 over 5x. So now I have 6 plus 45. That gives me 51 over 5x plus 13 equals 23. Now again, I want to get x by itself, so I need to get rid of this 13. It's a plus 13. The inverse operation to addition is subtraction. Whatever I do to the left side, I need to do to the right side. So I subtract 13 from both sides. I have 51 over 5x is equal to 10. Okay. Now, I multiply by the reciprocal to get rid of a fraction. So the reciprocal of 51 over 5 is 5 over 51. Multiply by 5 over 51. Okay, these cancel. X equals, okay. Now I can't cancel anything out with 51, so I just multiply across the top. X equals 50 over 51. Okay, 10 times 5 is 50. Let me write that a little bit bigger. X equals 50 over 51. That would be my answer. And again, if I wanted to check it, I could plug it back in and show that from the beginning, if I have 50 over 51 in for x, and it will make the equation true. Okay, but for now, my solution is 50 over 51, and I can't reduce that. Okay. All right. With that, now you guys will begin your classwork. So, the classwork will be coming out. The substitute will have the answer key, so please take this opportunity to try some problems to see if you are doing them correctly. With about 5 minutes left in the class period, the homework will come out, and we will review the lesson summary. So if you'd like, go ahead and pause the video right now, okay, and I'll be back to summarize the video with about 5 minutes left in class. Okay, so we should be back. There's only about 5 minutes left. Your homework should be on its way out. But our lesson summary, remember the properties of equality shown below are used to transform equations into simpler forms. The addition property, the subtraction property, the multiplication property, and the division property essentially mean we can add, subtract, multiply, and divide equations as long as we do the same thing to both sides of an equation. Okay, and to solve an equation, transform the equation until you get form of x equal to a constant. And again, a constant is a number. So we want x equals a number. For example, x equals 5. Okay, so go ahead and work on your problem set for whatever time we have left. That will be due on Monday. Due on Monday. Okay, for this class period. Okay. Alrighty, that's all I have for you, and always have a good day.